Okay. Sorry. So today's objective is we're going to look at an overview of chemistry with a focus on matter. Okay? So this is what it's going to look like. So you're going to use most of the paper. Okay? It will eventually go on page 26 and 27 of your notebook. It will be Cornell notes because you are going to have some questions here and some summaries, and your summary is bottom. But this is what it's going to look like. Now, I use color. You do not have to, but I suggest that you do. When we do concept maps, there's a reason for me to use the colors that I use. There's a reason for me to make the shapes the way I make them. And as I go through the lecture today, okay, I'm going to kind of make you look at why I make them the way I do. When you do concept maps, the best thing to do is to use color, to use different shapes. So the colors and the shapes give you an idea of what that word means. And you're going to see how I do that today. Okay? It's just a good strategy that you can have whenever you actually make your own concept maps. So you can make them more useful to you. Okay? Brianna, you had a question?
Oh, never mind.
Okay. Alright, so obviously our focus today is matter. Okay? So it's an overview of chemistry where we're going to learn this entire semester, but our focus today is matter. So let's talk about what is matter. You might have a definition for matter, you know what matter is. Raise your hand. Yes, what are you thinking? Matter is everything? Really?
Yeah.
Alright. Give me some examples of matter. Things that are matter. Things that you know is matter. Yes? Something that takes up space, okay? And there's 7 parts of that. Something that takes up space and... Yes? Those are states of matter. Yes, solids, liquids, and gases are states of matter. And all of them take up space and they have something else. So give me some examples of matter. A solid is a state. Table. What else?
Ice.
Ice.
Human.
Flag.
Water.
Water.
Gas.
Oxygen. Paper. Pencil. H2O, which is water. Okay, markers. Okay, binder. Erasers. Okay, so basically I can stand here and can you start calling out a bunch of stuff?
Yeah.
Okay. All of those things have 2 things in common. One, they take up space. The second, what else can you measure of every single one of those things? It's taking up space and volume. Very good, mass. So matter is anything that has mass and takes up space. That's what it is. Okay? So now, let's go back to Andrew's comment. Everything is matter. So the characteristic of matter is anything that has mass and takes up space. Does everything have mass and everything take up space? No. Okay, so I'm hearing yes, I'm hearing no. Let's go with the yes. Why do you think everything has mass and takes space? Okay, so you can measure mass and anything. Can I hear from someone of you that say no? Yes. That's antimatter, okay? Which we're not going to discuss, but there is antimatter, which is the opposite of matter, but that we're not going to that. We're just going to things that are not matter. Andrew? Light. Okay, so there's light going from that projector over here to my screen, right? Is
But we can't measure it.
Can I get the mass though? It does take a space. I guess the space of the room, I can see that it's here. But can I grab it somehow and get it the mass? Because it's not matter. So is everything matter?
No.
No. There are things that are matter. hydrogen is one of them. Anything on the periodic table, it's hard, but we can do. Okay? But there are some things that are not matter. We will be discussing those in our activity today. Okay? So right now, matter is anything that has mass and takes up space, right? So, separate was like, oh, solids, liquids, gases. The reason for it is because those are states of matter, or phases of matter. So sometimes they're called states, sometimes they're called states. Phases or states. So the four states or phases of matter are solids, liquids, gases. And last one is plasma. Everybody in this room up to this point know solids, liquids, and gases. You've known them for a long, long time now. My little cousin is in 2nd grade and he knows them. So I'm pretty sure you've known them, if not 2nd grade, at least 5th grade. You've known solids, liquids, and gases are states of matter. Okay? Now imagine one in there if you didn't know, and the fourth one is plasma. Okay? And we're going to discuss them. But the reason that plasma is not widely discussed is because even though it is the most abundant state of matter in the universe, we tend not to come in contact with it too much. More contact with the other three. Now, remember I told you that on my concept map I use different colors and shapes? What can you tell me about the shapes going from solid up to plasma?
They're more crazy.
They're more crazy, they're more irregular, right? They're also, aren't they a little wider and bigger? And the reason for it is because once we start looking at characteristics of solids, liquids, gases, and plasma, we're going to see that the way that the particles move in those four states get or become much more erratic or irregular, meaning they just go a little crazy. Okay? That's why I did it that way. There's a reason for those shapes. Because a solid tends to be very irregular. It has a specific shape. The other three don't have specific shapes. They can be whatever shape they feel like. Okay? So, there's a reason for my shapes, there's a reason for my colors. So, any questions over those four states, phases, and matter? We will be going into them in a little more detail tomorrow. Today is an overview. So, the other thing we're going to look at in this class is we're going to look at how matter is classified. Matter is classified in two major categories. Pure substances and mixtures. So let's go back to making a concept map. So look at how I wrote pure substances and look at how I wrote mixtures. So can somebody give me a difference between how I wrote pure substances and how I wrote mixtures? Yes, Jerry.
Substances that
Just how I wrote. Just give me specific how did I write. What's the difference between how I wrote pure substances to how I wrote mixtures? Okay. So pure substances I wrote in the same color. Mixtures I wrote in several colors, right? What else is different from how I wrote pure substances and how I wrote mixtures? Yes? Okay, very good. So in pure substances, it's a regular rectangle. In mixtures, I have a rectangle in sort of oval, right? So, looking at how I wrote them, does that give you an idea of what the difference is between pure substance and mixture? Brianna, what do you think is the main difference? By looking at how I wrote them, what do you think the main difference is between pure substance and mixture?
mixture, you have any object, and
So-
one using more pure substance, whatever, it's just that one thing, there's nothing other than
Okay, very good. Pure substances, basically, we know, are what we call pure, meaning there's nothing in there that's mixed very well. Okay, it's basically made of one major type of matter. Mixtures are made out of a bunch of different types of matter. Okay? Pure substances look completely the same. Isn't don't all those letters look exactly the same color? Okay? Mixtures, not necessarily. I can see the different parts. Okay? So, let's start looking at pure substances and how we look at those. Pure substances are then divided into two other categories, which are elements and compounds. So, looking at how I wrote elements and looking at how I wrote compounds, what do you think the major difference between those two are? Yes, Levi.
Elements are only
Okay.
compounds are mixtures.
Okay, very good. Okay, so elements is one type of substance. Compound is a mixture of two or more. Boy, compound is a mixture of two or more, but it's under pure substance. It's not under mixture. So this is a two or more. I can tell, right? Green and purple, right? Or pink, whatever you want to call it. Okay. I know that's two or more. Black or green, whatever that was, and yellow. But they're not in the same place, so they're probably a little different. So let's look at how I wrote them again. What is the major difference of how I wrote two different colors here to two different colors there?
Because one's pure and one's not.
Okay, yeah, we know one's pure and one's not. And? But compound, Levi's right, compound's made out of two or more different things.
It's because the compounds are easy. Compounds, you can take them out easily. They're not mixing together. Like if say you made a salad, you could take everything out. Even though it'll still be that one thing. It won't be mixing together.
Okay, so you're saying that that is compound, or you're saying that that is mixture? Well, once again, go back to how I wrote it. Look at this, compare to this. Which one would be easier to figure out and separate? This one, right? Can't you really tell the two different colors there? Aren't these colors kind of blended in? Okay, so which one's a little easier to pick out? This one, right? So you're right. This one's easy to pick out. This one's easy like a salad. Like you were saying, you have a salad, you can take a bunch of pieces. A salad is a mixture. A compound is two or more different things, but it's easy. It's not easy to separate. So who can give me an example of compound? Yes.
Like Kool-Aid mix.
Kool-Aid mix. Okay, I'm going to tell you how to separate it. If you go home and do it, don't tell your mom that I told you. Okay? Try this. And once again, don't tell your mom that I told you. Okay? Make Kool-Aid. Okay? Then you're going to put it on the stove and let all the water evaporate. And what you will find is you'll find that what you have left is burnt sugar and Kool-Aid. And once again, I didn't tell you how to do that because it's, and I'm sure your mom is not going to wash that pot. So that one would actually be a mixture, even though you can't see the little pieces, they're still there. And if you evaporate the water, the sugar can still be there, and it's going to melt and like get all caramelized. And then the Kool-Aid mix will also be, and that's going to mix with, it's going to be very gooey. Yeah, that would be a solution.
Could you eat?
Okay, you could eat that. I actually did something similar to that. I decorate cakes, so I did a mixture of sugar and water, like a lot of sugar and water. Then I put it on the stove because I needed to melt the sugar. So I melted all the sugar, the water evaporated, but before all the water evaporated, I melted all the sugar, put that over ice to make like coral like things. But basically, I took all the water off, then I put it in. But I could have just put the sugar on the stove. You have to make it with water. Okay. Okay. So, any questions over those two? Now, elements. Where do you find those? Gratitude. Okay. Compounds are two or more elements stuck together. And as we said before, we can't separate them, but it takes some time and it takes some work. When we do separate them, they go through what we call a chemical change. So compounds can change chemically. They can chemically be changed. When we do that, we have some signs that we see whenever that happens. Those signs you should already know. Because last year, you should have studied chemical and physical changes and looked at the differences between chemical and physical changes. So if we look at chemical changes and their signs, we know that sometimes they change the odor. Okay, if you leave trash out for a long period of time, doesn't it start smelling?
Yeah.
Okay, it starts smelling because there's chemical changes occurring. It's rotting, right? Once it rots, can it unrot?
No.
No, it's a chemical change. Change in color. Okay? The banana, whenever you leave it there for a long time, doesn't it turn black?
Yeah.
Okay? Can you make it yellow again? No, it's because there's a chemical change there. It's been maturing. I'm going to come back to makes precipitate. Makes bubbles. You put Alka-Seltzer in water, it starts bubbling. Okay? It's a chemical change. And then the last one over there is makes precipitates. Does anybody remember doing a lab with, if you had Miss Kurtz, you did.
Oh, yeah.
Okay? Yeah, I think she used small test tubes. And you mix two different chemicals. It would, I think it turned blue or something, the liquid turned blue. And at the bottom you ended up with a solid. When you put two liquids in, you got a solid at the bottom. That solid is a precipitate. Okay? So that's a sign of a chemical change. So, for pure substances, two major categories, elements and compounds. These are not easily separated. These can't be separated at all because it's just one thing. These can, but it takes a while and it has to go through a chemical change. So that takes us over to the mixture side. Is that okay for everybody if I just leave it there? Okay. So if I go to the mixture side, there are two types of mixtures. There's homogeneous mixtures and there's heterogeneous mixtures. Now, remember when we talked about that psychrometer and I said, you know, I know science has all these big words, but if you learn some prefixes and suffixes, it's going to help you. Okay? Here's two prefixes that you're going to come in contact with, and by the way, you already did. Okay? Which are homo and hetero. Everybody in here has heard the prefixes homo, much more than hetero, but definitely homo. Okay? And all those prefixes mean is homo means same. Hetero means different. Homogeneous means looks the same. Geneous means looks, appearance. Heterogeneous means looks, appearance is different. Now, you're going to sit there, and I know you're already thinking about it. I know it. Everybody in here, once again, has heard the prefix homo in homosexual. Well, guess what? Homosexual means same sex. A person that's homosexual likes who? The same gender, right? Yes or no?
Yeah.
Yes, and you know you're thinking of it. No, you're not. Okay, so homo means the same. That's why they're called homosexuals, because they like the same gender, the same sex. Homo means same. Later on in biology, you're gonna learn homozygous. Same genes. Heterozygous. Different genes. So here we're talking about appearance. So in homogeneous compared to heterogeneous. Look at how I wrote them. What do you see in homogeneous? It's the same color. What do you see in heterogeneous? Different colors. Okay? Now, a homogeneous mixture is also called a solution. Basically, it is a mixture that looks the same. It is a mixture such as the Kool-Aid. The Kool-Aid would be a homogeneous mixture. What do you have in it? Water, sugar, and the Kool-Aid mix, right? So you have three different things, but can you see all three pieces once you dissolve it all in? No. So it's a homogeneous mixture. A heterogeneous mixture is one in which you have a bunch of things and you can see it. For example, chicken noodle soup. In chicken noodle soup, you have chicken, you have noodles, you probably have some vegetables in there, and you have the chicken broth. So can you see those different parts? Yes. So that would be considered a heterogeneous mixture. Okay? So any questions over those? And then I said, we're going to talk a little bit more detail, definitely tomorrow, about some of these things. Alright, now let's talk about this last thing here, water. I have a line going from water to solutions, meaning that water is a solution. And a line going from water to compound, meaning that water is a compound. So according to that, excuse me, I'm on this. Okay. Andrew, one second. As soon as we're done, go up. So, not yet. As soon as we're done. Alright, so how can water be both a solution and a compound? Both something I can separate easily and something I cannot separate easily. How is that possible? How is it possible that water can be classified both a compound and a solution at the same time? Think about it. How can it be a compound that we know can't be separated easily? It has to go through a chemical reaction in order to separate. And it can also be a mixture that we know we can separate through some physical changes. How is that possible? Why can we classify water both of those? What are you saying, Andrew?
You can freeze it and evaporate it.
Okay, so if I freeze and evaporate it, then just changing the state of matter, which we can, you're right. But how does that explain that it can be both a compound that we can't separate easily and a mixture that we can? Does anybody know what the compound for water is? H2O. H2O, right? Everybody knows that. H2O is a compound? Yes? Okay, what is in H2O? Hydrogen, oxygen, they're chemically combined and chemically stuck together, right? And it's very hard for me to separate that. I actually can, but I'd have to put in a tremendous amount of electrical current for that. Okay? And then I would get hydrogen gas and oxygen gas, which are both explosive. Alright? So it's not easy to do that. So that's a compound. But how we know that about H2O, how can water also be classified as a mixture? If I get water from here from the faucet, is it just H2O? It's not?
Yeah.
Why do you think it's not? Very good. He says, because they add chemicals in water. If I take water out of here, is it just pure H2O?
No.
No. Don't they put chemicals in there to clean it up? Because we recycle the water? Okay? Whenever you go drink out of the water faucet, doesn't sometimes it taste like metal?
Yeah.
Okay? Doesn't it have some minerals? Yeah, right? So think about it. If I have the water that's coming out of here, H2O is in there because it's water. But that's not the only compound in there. Okay, I might have some iron in there. Okay, I might have some bacteria in there. You probably do. Okay, I might have some algae in there. If you go to the beach, you're going to have some salt in there, salt water. Okay, so it's still water. When you go to the beach, you're like, ooh, salt water. No, you're saying it's water, correct?
Yes.
So that water is a solution because you have other things in there. Okay, so when we talk about water, you need to be very careful and make sure that you pay attention. Is it talking about H2O water, which is a compound, or just water in general that we get out of the tap, which would end up being a mixture? Okay, so just make sure that you notice the difference whenever you're reading different things. All right, any questions over there? Okay, so we are going to do an activity. in just a second, but in the sense of getting it all on video. Let me go ahead and give your special assignment for the week. So everybody turn to page 28 in their notebook. Our special assignment for the week is grasping matter. Okay? Basically, what you're going to do is you're going to, on page 28, title it Grasping Matter. You're going to put your hand in there, and you're going to trace it. Okay? So you're going to go ahead and put your hand on your page 28, and go ahead and trace a hand. Okay? You can put your fingers really far apart, you can put them close together, it doesn't really matter as long as I see a hand. Okay? So, do that now. So the title is Grasping Matter, and just trace your hand on your paper. And you can't tell me you can't do it because I did it. So if I can do it, you can. Okay? Alright, so in the palm, you're going to write the word matter because that's what we're talking about. And you might want to draw it all pretty and neat. Okay? Bless you. Yeah, that's better. On the 4 fingers, so 1, 2, 3, 4, on these 4 fingers, you're going to draw pictures describing characteristics of the 4 phases of matter. So, one of them will be solids, 1 liquids, 1 gas, 1 plasma. You're also going to include and make sure that the pictures are showing energy. Now, this is what I do not want to see. I don't want you to draw an ice cube, water, and water vapor, and then a lightning bolt, because I'm going to talk about that later. I don't want to see that. That ice cube is not showing me that you understand the characteristics of a solid. So your pictures need to be, you need to really think about what is going to show you the different characteristics. Okay? Tomorrow when we have our notes, we're going to talk about those. Okay, but I just wanted to go ahead and give it to you now. Alright, so any questions on the pictures over here? Then you're going to have a picture in your thumb area, so your thumb, of not matter. So the picture here is going to be symbolizing something that is not matter. Okay? Something that doesn't have mass or doesn't have bond. So the only word on this hand is this word. Everything else is picture. Okay? Then, at the bottom, you're going to write a paragraph describing your pictures, why you chose them to help you remember the characteristics. So, and this is what some of you are thinking. Miss, but my hand's really big. It took most of the paper. It's okay. Write the paragraph in another piece of paper and then tape it on it. It's not a big deal. Okay? All right. So, any questions over this? You're going to get a little more a feel for what you can draw whenever we do the notes tomorrow. But I wanted to go ahead and give you the instructions. Any questions? Okay. So, don't close this. Just put this aside. And I need everybody should have a package like this on your table. If you don't, I'll give you one in just a second. Go ahead and get those cards out, and I'll give you your activity in just a second.